Hello, I'm Elizabeth Biddinger, and I'm an associate professor in chemical engineering at the City College of New York, which is part of the City University of New York, or CUNY system. I'm also the director of a PhD program at City College in chemical engineering. And today I'm going to share with you some about my research in the Green Chemistry and Energy Research Group. My research falls into two main categories. The first is in electrification of the chemical manufacturing, and the second is in battery electrolyte engineering. And so first I'll share with you about the electrification of the chemical industry. So we do electrification of chemical and fuel production for a variety of reasons. And so we want to utilize the excess renewable electricity that comes from solar and wind. It's also very cheap electricity, becoming one of the cheapest energy sources that we can use for chemical processes. We want to use this to make fuels and chemicals. And what this will do for us is allow us to reduce the CO2 emissions, or even utilize CO2 as a reactant, thereby dealing with some of the global warming challenges that we have. It also can help us eliminate the reliance on fossil fuels. And so the picture I have here, we have an electrochemical reactor, is which the technique that we're using uses electricity directly to put in waste or CO2 and biomass. And then we can do the electrochemical reaction and have the products come out, and they're separated by oxidation products and reduction products. We can then use these, and then hopefully we can actually close the carbon cycle in the process. And so in my research group, our approaches currently are to use the electrochemical applications to convert the chemicals, which might be from biomass, such as agricultural wastes, or from carbon dioxide, to fuels and valuable chemicals. In my group, we are trying to understand how the reactions behave so they can be improved and then be able to be implemented industrially. And so we're doing a number of reaction engineering and characterization techniques to be able to do this. The second area of research in my group is on applying to energy storage and really looking at using electrolytes for both performance and safety. Particularly the energy storage we're looking at is batteries. And so we're looking at electrolyte engineering to be able to prevent the flammability risks by having minimal vapor pressure electrolytes, or electrolytes that may actually switch off when we have heating during the battery undesirably. And we want to also improve low temperature and radiation stability, as we're also looking at applications that are interest to NASA's space missions. And we want to generally improve the battery performance. So here's an example that we've worked on in the past on some electrolyte engineering to improve the safety. So in a traditional electrochemical cell, it's actually a battery, you have an electrolyte that allows the flow of ions, and that helps create complete the circuit for the generation of power. Now, when we have an undesired thermal excursion, what we don't want is to have a fire or an explosion. And so in this technique that we're using, we actually have a thermal switch built into the electrolyte that causes the electrolyte conductivity to essentially go to zero, and then stops the ion flow in the battery. This essentially causes the circuit to open and then allows the battery to cool. Upon cooling, we can return to normal operating temperature. And so this is a concept that we've been working with using a variety of ionic liquids and other ionic liquid-like electrolytes. And so in my group, we are using electrochemistry, reaction engineering, novel electrolytes like ionic liquids, catalysis, and keeping in mind that we want to look at applications that are sustainable and consider green chemistry. And so I would be happy to interact with you further about research. Most researchers that join my group do not have electrochemistry backgrounds to begin with, though they learn in the lab. So feel free to email me, and otherwise, I look forward to hearing from you. Thank you.